Lovely. Thank you very much. Good morning, everyone. Thank you for joining us today on day 2 at this panel, which is a very important topic in society for the conference, and I think for the SSI going forward as well. So we're very excited to have brought together some amazing speakers on this topic. I will not be doing this sort of formal introductions of the speakers where I try to summarize their CVs in a few lines. I will leave the speakers to introduce themselves. So to introduce themselves a little bit and a little bit on the topic they're talking about. The format then is that we will have 2 main topics today. The panel will first look at the idea of how researchers and organizations can collaborate to normalize monitoring and estimating carbon footprint in digital research, and specifically AI. And once better understood, how can this data be used effectively to enable cultural change? So we'll start off with the introductions. We'll talk about some of the challenges around carbon footprint. There'll be a little bit of a Q&A, and then we'll move on to the second topic of cultural change, after which there will be another little bit Q&A on that topic and a general broader discussion. Let me just start directly off with our first speaker, Kirsty, to introduce herself. And I will share a slide. Here is the Slido. As you realize, there'll be questions straight after this topic, so please start asking your questions on Slido. I'll leave that up for a second. So Loïc can have a look as well. And all of the links are in the document as well. And then I'll give the word to Kirsty. Kirsty.
Thank you. So yeah, hi, my name is Kirsty Pringle. I work for the Software Sustainability Institute based in Edinburgh. Before I joined the SSI, I was a researcher looking at using climate models, basically climate and atmospheric models for my research. And then I made the exciting transition from being a climate researcher into being kind of an embedded research software engineer, helping other people use the models. So my background is really, or my interest is really in climate and also in research software. So I'm really excited to see the community come together and place a lot of importance on the environmental impact of the work that we're doing, because while the work's vitally important, there is an environmental impact to it. So I'm really excited to see that being taken into consideration. So in terms of introduction, in terms of what I think, my own personal wisdom, the 3 things that I think are particularly important in this topic. The first is community, and I could have just written community, 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 because it is just so important. It's a way of developing good practices. It's a way of sharing knowledge. It's a way of providing support. It's a way of making sure that people that do this work are rewarded for it. And so I think that's absolutely vital when we talk about making that change. And it takes time, it takes effort to build a community. The others are in communication. Firstly, raising awareness of the issue. That's absolutely obvious. But then the other is kind of listening to the community. If we're asking people to make changes, what are the challenges that they're facing, to make sure that we can kind of address those, we can identify large scale challenges and kind of help smooth that road. And then finally, really thinking about it as a cultural change. This is a big shift that we're asking people to do. I think we need to be in a situation where metrics are routinely calculated and published. And it's just normal. It's just part of the research process. But in order to make that, there's a big cultural change required. And we really need to see it as a cultural change, I think. And that, I think, helps frame the importance of the question and the size of the ask that we're making. That's it.
Thank you very much. Then I'll pass the microphone on to our second speaker.
Thank you. I'll need to change slides, so I'll go there. Hi, everyone. I'm Loïc Lannelongue. Just very briefly, I do research in partly in computational biology and cardiovascular research, but I actually spend a lot of time on these green algorithms projects, so building tools around to estimate environmental impacts of computing. So that's, if you're interested, everything's on the website, or please do find me. Very happy to chat about that. I wanted to mostly use this time to talk about 2 super exciting projects coming up that we haven't really announced yet anywhere. So that's kind of cool for the collaboration workshop. And the SSI has been really important in both of them. both long time in coming. So the first place is a community of practice. You heard Kirsty yesterday talk about a special interest group for RSCs, and that's super important. And the idea is to complement that with a somehow broader community of practice for applied scientists, but not only a place also for RSCs, but also sustainability people. Anyone who has an interest in computational sustainability, environmental sustainability, can go and ask questions, share resources, talk. So we've just launched this platform. So the idea is to build it together. So I'll put on the Slack just when I'm done a link, so that would be easier. And if anyone who has an interest in the topic can just join up and post one thing to kind of start building it before we announce it more broadly in the next couple of weeks. Ultimately, the idea is to have this online platform as a forum, but also have some kind of mailing list and regular meetups. So if that's of interest at all, yeah, do check this out. And the second thing is sustainability certification. So we called it Green Disc. You wouldn't imagine how hard it is to find a name. So any complaint, please don't share. No, you can share feedback or suggestions. We haven't launched it yet. The idea of that is some of you may be familiar with certifications like LEAF for wet lab sustainability, and there's been a real need for the same thing for dry labs. I have so many emails in my mailbox asking to do the same thing. So we have that. We piloted it last year, it went really well. We're hoping to announce it more broadly in the next few weeks. Individual labs, research institute can get some kind of bronze, silver, gold certification, a bit similar to Athena's one, again for EDI. And yeah, so that's coming up. That's very exciting. The best place to keep an eye for that is to join the community of practice because we'll announce it there. But I'm sure I'll post it on the Slack and I'll spam people. So yeah, that's me done.
Thank you very much. Now I can hear people thinking, are they going to have a panel with just 2 speakers here and 1 chair? There are actually 2 more people, but they are online because the collaboration workshop is hybrid. So please allow me to move on to our 3rd speaker. That will take a little second.
So I'm Michael, hi from Manchester. I'm a senior lecturer at Manchester Metropolitan University in green software engineering, and I'm interested in all aspects of green software engineering. I got involved in the Net Zero Digital Research Infrastructure report that was what helped write it to UKRI last year. I'm interested in the whole kind of workflow from measuring and monitoring and then being able to predict what the carbon footprint of various simulations would be. But most importantly, how we're going to reduce this. I feel there's an urgency. We've got to get this urgency. You know, climate emergency is here now. We need to reduce by 3 orders of magnitude the carbon footprint of IT. So in that, we don't need to measure everything absolutely accurately to the nearest tenth of a joule or anything. We need to get a ballpark figure and start reducing by orders of magnitude of the carbon footprint of that. And we've got to bear in mind there's both operational footprints, the energy that we use to run the PCs, etc., and the carbon emissions that are associated with that, but also in the production of the hardware as well. So one way of reducing all this is just to run your servers longer, not to buy a new mobile phone every year. And I also think we need to step back, use pen and paper a lot more. Think about what it is we want to run before we start just banging off a load of simulations just to see what happens. We need, as Kirsty said, like a cultural change, a step change. We need to kind of almost justify to ourselves and to each other, why are we going to use this carbon? We don't just go and test on animals just like that. So why are we going to stick carbon in the atmosphere and screw it up for future generations? So maximizing current resources, bringing all this together in terms of a smart green scheduler. Not everyone will be able to work out everything. The more I look at green software engineering, the more and more complex it is, the more and more interaction. So let's work together, get a smart green scheduler. Everyone can put in different bits, whether it's prediction or where we're going to run. Make sure we can reduce energy as much as possible and then use the greenest energy that we can. In terms of education and community, yeah, we need a team of not just research software engineers, but green software engineers. So I'm kind of chasing grants to get that off the ground, and also similar to Loïc, setting up a repository for all the best practices and stuff, and that's under the banner of greencompute.uk. That's me. Over to Cass, I guess.
Thank you very much. Cass, would you like to share your screen?
Great, thank you. I can see the room, so I can see my slides are up there. Thank you so much. So my name's Cass, my pronouns are she, her. I'm not a software engineer, I'm a research community manager, but in my job before becoming a community manager, I was a neuroscientist in working in psychiatry and psychology and things. So I'm one of those self-taught people. My current job is as a community manager is for Environment and Sustainability Grand Challenge at the Alan Turing Institute. So we all work at Turing is now sort of being collected under our three main themes of Grand Challenge, and then some fundamental work as well. And the Grand Challenge, like as a focus, kind of says that we as Turing recognize the scale of this issue. And not only are we doing active research in the area, but we're also putting a lot of infrastructure positions in place to support delivery of the Grand Challenge. And I'm one of those as a community manager. We also have software engineers, data wranglers, and program managers and things like this as well. So I wanted to, obviously, community is something that everyone has talked about and we all recognize is important to this. So I wanted to say a little bit about how we formally do community management. And there's the first project that I wanted to bring to your attention is our stakeholder map. So I've linked this on Slack in my introductions post, but I can also put the links again. So with the stakeholder map, what we're trying to do is to collect people working in data science for environment and sustainability. So they can be private sector, public sector, and researchers. And these are, the way we're collecting these folks is that they are individuals who have signaled that they are willing to collaborate and are interested in collaborating and joining a community. And they've signaled that intent by engaging with us. So that's either on our Slack or on our mailing list, or they've been to one of our events. And not only are we looking for people with like a low level signal of intent by joining a mailing list, but we're also looking for people who are the most engaged. So the people who keep coming back to our events and the people that are actively contributing to our community. So in that way, we're looking for people who do want to work with others. And as at the Turing and TPS, Tools, Practices and Systems, we operate under the general principle of the best research that you can do is open, collaborative, reproducible and ethical. So everything that we're designing for this community, all of these people that we're finding and plotting on our map, is trying to help them achieve that reproducible, ethical, collaborative, open practice. So this little GIF here just shows you that the map that we're making is for you as much as it is for us. So we're using it to, we're doing network analysis to monitor the community health and growth, but it's also for you to help you find each other and help you develop routes to dissemination and understand the space, because this is a big space. And I'm thinking I might need to add communities as another level on the map. So do some kind of meta community work, because there's a lot of communities as well. So this is a tool to help you understand the area that you're working in. And as it says on the bullet points there, our goal with this work is to understand the distribution of power in these communities and these different institutions, and see how we can contribute to distributing that further into the lower levels. So all of this work can become bottom up and we can all have paths to impact. And then the other part of how we operate is using this model called the Mountain of Engagement, which is a Mozilla model, and it came to me by Open Life Sciences. I think there's some OLS alumni in the audience with us today. And this is an understanding that everyone who participates in community is positioned somewhere on this mountain of engagement. So either they are just discovering this community, or they are in contact with us. They could be participating, they could be regularly participating, or they could be building the network internally and bringing people into our community, or they're in a position of leadership. So everything that we do is designed to help people transition up and then down the mountain if and when they need to pull back from their community activities, But the more people we can progress into leadership opportunities, the more sustainable the community is, then it starts to have a life of its own. And it's not just something that's always coming from us in a kind of outwardly directed thing. We want people to be leading the community and then developing the things that they're interested in doing, because they'll be more engaged and more motivated to do things that they are interested in. So do feel free to reach out to me if you want to talk about stakeholder mapping. The tool that I'm using here is Kumu. It's fabulous, and I'm very happy to talk about any parts of that. Thank you.
Perfect. Thank you very much. I can see some questions coming in on the Slido, so please do keep asking those questions there and upvoting or voting your favorites. I just wanted to, I think the speakers have made the argument of the urgency of the action. I think this room here also understands the urgency, but there's a question of what can we do to reduce it? Also, I want to sort of find that together with the challenges of calculating carbon footprints. And I just wanted to first get a response from Michael, maybe on that topic. Would you want to respond to that, Michael?
Sorry, on which particular question?
So you spoke a little bit about the urgency of this problem, but what can we do in concrete terms to reduce it, and what are the challenges of calculating carbon footprints?
So for people doing low-level coding, if you're doing it in Linux or any other form of Unix, you can look at counters on CPUs and you can get energy measurements that way. If you're running on Archer, you can get energy measurements that way. All of this is, cloud is a lot harder, I must admit. All of this is going to give you how much energy your code takes. Doing less in terms of not running the code as often, looking at the precision of your code, moving from doubles to floats, looking at different algorithms that maybe do things quicker or use less power when then doing the operations are all ways of participating. If you're running a center or you're involved in procurement, then extending the life cycle, the lifetime of your kit from 3 years to 6 years or something like that will make a very, very dramatic difference. For the footprint of the server, it takes as much carbon to make as it does in 3 years of running it, roughly speaking. So we shouldn't be binning them and just getting new ones just like that. Obviously, there's also things about water, minerals, and where all these come from in the global south. In terms of the urgency, everyone wants to get to net zero either by 2030 or 2050, but that really, you know, the definition of that is to reduce current emissions by 80 to 90%, and then with what's left, use renewables. So we're looking at getting orders of magnitude reductions in what we do. Does anyone else want to chip in?
Okay, I can go. Well, I guess I'll start with the quantification because that's what I do a lot of, and people who had the speed blog yesterday will be incredibly bored because that will be the same thing. But there are basically 3 main ways to estimate the carbon footprint. So roughly, you either put a Python package in your code and that tracks what you're doing while you're doing it, and it will give you a report after that. Or you use an online calculator like the green algorithm one we did, where it's a bit like a flight calculator. You say, my model runs for that long, I'm using this kind of hardware, this is where I'm in the world, and it gives you an estimate of carbon footprint. And the third option is to go on the server side. So use if you use HPC or if you're on a data center, everything you do gets logged. And so you can track or estimate carbon footprint based on the logs. And they all have pros and cons. If you're not doing Python, the Python option is obviously out. And so it really depends. There are quite a lot of literature now. And if you want to check the website, whatever, there are lots of about what the best option. All of those are mostly estimates and not relying on measurements. And Michael was mentioning, in some cases, we can actually measure it. But I think this is probably a longer discussion. We spent an hour and a half yesterday discussing the two. So if you're interested, check out the SSI blog post that will come out at some point. On the aspect.
I was going to chip in. All of that is energy, but what we're really concerned about is the carbon footprint. So not all electricity is equally as green, depending on the mix of how much is renewable and how much is fossil fuel. So one way of perhaps halving your carbon footprint is having a look at when you run things. So you can look at, there's a widget on the WWF website, will tell you the carbon intensity when it's high or when it's lower. It doesn't just apply to running code, it applies to all, all your electricity use when you do your washing or things like that. So by timing when, and if you can, where you run stuff, you can dramatically reduce your carbon footprint for whatever amount of energy you've already reduced from in the first place. So there's kind of two stages: reduce what you're doing to reduce the energy, and then you use the greenest energy possible for that piece of work. Sorry, Loïc.
Yeah. No, yeah, totally. And most of these tools will report both usually. But on the when to run, in the UK, we're quite lucky. There's this website called carbonintensity.co.uk, something like that. It's done by the National Grid, and it gives a 48 hours forecast of carbon intensity. So what's the carbon footprint of using electricity in the UK by region for the upcoming 48 hours? And that was something that the CATS team, so lots of people are here, that we did last year at the collaboration for the Hack Day. That's basically what's the best time window to run the code in the upcoming 48 hours, using exactly that, saying using this forecast was the greenest time to do it. So that's one of the cool way to do that. Yeah,
I think that's really interesting. I think another thing that is very important is to really understand what the research workflow is. So if you were, for example, you publish a paper and you say, yeah, I use these simulations and I've used this tool and an estimate of how much carbon that produced. But that doesn't necessarily say that I ran 20 simulations to develop the one simulation that I used in my paper. I mean, we need to be open about the full research workflow, and that involves development. If you're developing a model, it can take a lot of simulations before you end up with the simulation that you actually publish, which is normal. But we really need to be thinking about how we design this development and how we design experiments to make sure, and that's the full experiment, not just the little bit that gets published at the end. I think it's really interesting because a lot of the open and kind of good software practices actually also feed into this as well. Often the good practices are the practices which minimize mistakes and therefore minimize the fact that you've realized that you've got a bug in your code and therefore you need to rerun it. So that's also minimizing the environmental footprint. But I think there's a real, academics are always so busy and they're always so urgent, like you want to get this done. You have this feeling of, you know, progress when you're running a simulation or something like that. You think, oh, I'm working towards this goal. There's very little kind of pressure to kind of take a step back, check everything's right, to minimize mistakes. And I think if we can somehow, I think the research software engineering community is already very good at doing that. But if we can kind of help the research community to do that, to really think about, to kind of be very, I'm terrible at doing this, so it's really bad for me to say, but if we can really be conscious of the work that we're doing and planning it out at the different stages for that impact, I think that could make a really big change. And there's often a kind of a feeling that you should be running new simulations rather than analyzing old simulations. You should be collecting new data rather than analyzing old data. And actually, scientifically, we can get a huge amount out of data that we've already generated, but it's hard to get funding to analyze old data. It's hard to kind of gather that excitement about analyzing old data. And often, scientifically, the same questions could be answered by each. So I feel that we really need to kind of celebrate the people that are making good use of data that already exists or being careful with the simulations that they run. And that's I think that's quite a big challenge in terms of working with how people work.
Cass, oh, sorry, Cass had her hand up. Sorry, Michael. Cass, would you like to respond?
Thank you. Yeah, I just wanted to pick up on Kirsty's comment about good practice minimizing mistakes. And one of the things I heard in this kind of area is don't buy tech, don't buy more tech, hire more people. You know, the resource of a person, they're already using as much carbon as they're going to use, right? So putting another person in the project who can check your code to minimize mistakes so you don't have to run the simulation so many times, I think is a really interesting way that we can minimize the impact in this space. And in the same vein, collaborating together, more people doing a more a carefully designed, more robust research, I think is going to be less impactful than lots of groups doing lots of little bits. So it's about working together and capitalizing on the skills that and things that we can all contribute to this type of workflow, rather than trying to do it together and trying to do it separately and making our separate mistakes.
Did you want to briefly respond? Then we can go on to some Slido questions.
I was just going to say, back in terms of the scale of impact, and given that AI was mentioned in the abstract of this, one of the papers that launched the green AI movement, if you want to call it that, calculated that the total carbon cost of not just doing the training, the inference, but all the tuning of original AI codes was the equivalent to having 5 cars on the road for the whole lifetime. So, you know, a massive footprint. And the majority of that, similar to what Kirsty was saying, was actually in the tuning, sorting out the hyperparameters, not just doing stuff, but kind of the experimentation to find the best way of doing it. And I totally endorse going back to pen and paper, thinking about it, and only doing what you need to do. And my impression is that UKRI are at least seriously considering that one of the ways forward might be to consider putting, you know, the use of carbon in a similar vein to the ethics, the use of animals and things like that. So we would all have to think about how we are going to do things before we do it. Thank you.
Thank you. I think that leads nicely on to our next topic on cultural change, but there is I would say burning question on Slido, which got upvoted a lot, and let me just read it out. It's carbon footprints were popularized by BP, their carbon footprint calculator, to deflect attention from corporate choices onto the choices an individual makes. Who are the equivalent corporations we should be pressuring to make software have less of an impact on the environment? As Loïc being handed a microphone.
I can go. I can have a go. I don't think it's about making software more efficient, because, well, so much of code is done by researchers or individual coders. It's making data available. So a big part of being able to understand our environmental impact, and that's much broader than carbon footprint, is having data about the hardware we use, about the facility we use. And then we start moving to cloud providers. It's kind of the easy one. Everything else is kind of easy unless you have to estimate the carbon footprint of doing work on the cloud. And then it's a complete nightmare, because you don't know where the data center are. You don't really know what hardware is being used. You don't know where the energy is coming from. And so having more transparency on that, which I'm sure comes with massive PR issues, but it's not that difficult to do in practice, would go a very long way into making sure people know how to run their code in the most sustainable way, or can make informed choices.
Okay, thank you very much. There are lots of other questions here, and these will be archived, and we'll hopefully have time to answer them. But I just wanted to move on, because we were almost going there already, this cultural change. Michael talked about funders potentially including in this sort of idea as an ethics, as a part of the ethics considerations for proposals. So I wondered if you wanted to talk a little bit more about that, and then we'll see if we can move this discussion into the cultural change of what individuals and institutions can do, and in the end also how can we grow community, so growing communities as well. Michael?
I didn't really have much to add to that bit, but I think it is incumbent on us and the people we work with to treat carbon very, very as a precious commodity, and literally not just burn it away. So going back to education, not everyone gets there is a climate emergency, explaining that. Maybe we should have done that at the beginning of this session as well. But what is the role of ICT? You know, it's somewhere between 10 and 20%, but it's still significant, and it's probably growing with the advent of everyone taking up ChatGPT and things like that. And then there's a load of education about. One of the questions is, what can each of us do? What is the most impactful thing we can do? So I think education is the key thing here. I can't speak on behalf of UKRI. I hope they would introduce things like you have to justify carbon. I hope institutions would introduce carbon caps of people who kind of have to operate within a certain amount of carbon, which as a method to help them think what they need to do. None of this means don't do research. I mean, at the moment we have to bid for money and make the case, but we need to move that to bid for carbon to make the case, in my personal opinion. And we need to do that yesterday, 10 years ago. We've known this is a problem for 30 years and we're still burning coal and things.
Yeah, there's still some challenges there then still. Let me add a question from the Slido. Does better preservation and discoverability of results, instead of treating computation as cheap enough to repeat, have a role to play? And how can libraries, archives, repositories help?
I mean,
like to...
yeah, I think it definitely does. It's something this community is already does quite well. I think it's more whether, in my opinion, whether we as a community can kind of pass that out with this community and help others adopt these practices that many within this community already do. I think it's a nice additional argument for why we need to be doing this. I do think there's a challenge of discoverability to make sure that you're to make it easy enough to find the information that you're looking for and to make it easy enough to understand exactly what's contained within that. But yeah, no, I think it's a really important and positive thing to do.
I can jump on that. I think it links to the cultural change. So it's all about cost and benefit. And obviously, we're not saying, I mean, I don't think any of us are saying we shouldn't do compute, we shouldn't do AI anymore. It's just being like, Michael mentioned the idea of acknowledging environmental cost, and the financial cost is a problem. Computing is very cheap. You rarely hear someone say, we're not going to do this computational simulation because it's too expensive. That just doesn't happen that much. And it's very lucky and means we can do great research. But as a consequence, we just end up wasting it. So whether it is aligning financial costs with environmental costs, or it is just setting environmental costs in a different category and forcing people to acknowledge it. Interestingly, it was mentioned pushing funders and UKI in this direction. The French government decided to do it. So all the AI calls, they decided that if you want to apply for an AI national fundings, you need to estimate and acknowledge your carbon footprint in it. And interestingly, it didn't break science. That was the big conclusion of it. Is like, they just decided to do it and people understood why they were doing it. And when there are millions of pounds on the table, people do it and spend a few hours. So I think we can do a lot more in this space than we suspect we could.
Well, that's very reassuring. Cass, you had your hand raised. Would you like to respond?
Thank you. So pleased it didn't break science. So when I talk to departments and IT infrastructure teams about the fact that we want to store our data and we want to make it openly available, the question that comes up often is like, what's the return for us? How do we know that putting all of the money and carbon into keep making our data available and making it well, like doing all the stewarding and stuff, how are we going to know that that's benefited us? And I think there's an interesting problem here in the lag of data going into the community, data being made open, and then it being picked up and used in someone else's work. And I think as a community, we're quite comfortable with the idea that I can put a paper out and that paper has taken maybe 2 years to publish, like to get to the point from the start of the project to actually publish. And then it might be another year plus before I start to see any citations on that paper, unless it's in Nature, or, but everyone wants to know that their data's out and they want to see instant return for them. They want to see instant benefit. So not only have we got the thing about, making sure people are citing our data and code properly, but how do we get the folks at the top to be comfortable with the idea that it might be slow, right? We're not going to see an instant payback for the work that we're putting in to making our data available, but it's still worthwhile doing. And I haven't yet resolved that. It's a question that comes up all the time. But it's curious to me that people don't see the parallels with how it is with our research and our publications, and they're not willing to accept that this other version of it should be acceptable as well.
Thank you very much. I just wanted to ask another question from the audience. It's a broader question, so feel free to respond to how you see fit. And it's, what are the key changes to policies and procedures in research? So what are the key changes in policies and procedures in research are needed to incentivize green software engineering? Yeah, I'm aware Michael has to leave us also quickly.
I do. I think the fact we've got this panel, hopefully people are interested. I think it's unfortunately a bit of a slow burn to get people incentivized to do things, but I think kind of both top down and bottom up, us grassroots driving it. People like the Green Software Foundation have got big companies on board to do it, getting governmental, like Loïc was talking about, France, funders. We just need everyone to kind of realize the more you can do now, the more likely is we're going to meet net zero, and the more chance there is of keeping the global average increase in temperature as low as limited to 1.5 degrees. We don't want to go higher than that. You know, we've seen all the extreme weather. This is just the beginning, in my personal opinion. If we don't sort it, I don't know what's going to be like for my grandson and granddaughter, etc.
Okay, thank you very much. I just wanted to, before you leave, Michael, thank you very much. If we have a quick round of applause.
Cheers.
Michael posted a few links in the chat, which we will distribute. But yeah, it's also nice to have a mid-panel applause.
I can,
but we're not done yet. Yeah.
well, I can jump on that.
Yes, sir.
The main policy, I would say there are two things. Kind of opposite. One of them is to invest on dedicated work into sustainable computing. So whether it is to fund green RSCs or it is to fund tools to work on sustainability, like fund people so that they can dedicate their time working on sustainability rather than that being a kind of unfunded side project. And on the other end of the spectrum is to actually make it easy for environmental sustainability to be a part of everyone's work. That is not a big burden. We mentioned ethics. It's exactly the way to think about it. Like medical researchers have to think about ethics all the time. They don't consider it to be, you know, an extra part. That's just part of doing clinical trials. And so environmental sustainability can be the same. Which just means involving them as a normal part of grant application, for example. Like it just makes sense to have environmental impact statements in grants, and we talked about France and it worked. And we're getting to a point where we kind of have the tools to start introducing it. I'm not saying it should be used as a hard and fast rules and say if you're over that much, you're not getting funded, not at all. But start making it normal practice for people to have to acknowledge the environmental cost in applications, in publications as well. And I think if we do these two things, like normalizing, but also supporting some targeted, dedicated effort, I think we can make massive strides.
I totally agree. And I think to add to that, I would really like to see some of that targeted effort used to help academics fill in these applications in order to what we're asking for is a fairly quick transition. And if we can use some of that, the skill, the people that have chosen to focus on this area to help others kind of overcome those first initial hurdles, I think that would make it much easier. And then I could imagine a situation where I'm writing a grant, I need to fill out my environmental statement. I could just go and speak to the environmental person at the university who has experience of doing this, who knows approximately what I should be thinking about, what I should be considering, in the same way that I would ask someone that was an expert in ethics when I have to do an ethics application. So I would really like to see that normalized and also recognized in terms of it being a really useful and important role that would really help kind of minimize the extent to which this would be a burden on already very busy researchers.
Yes, please.
Thank you. Yeah, 100% everything Kirsty's saying, but then I also wanted to, the general practice that I like around behavior change is to support something, the thing you want to see, support it, reward it, and celebrate it. And what we've been talking about is supporting it, and that's fantastic. But there's a big problem with the way that this is viewed, or potentially a big problem with the way this is viewed from some levels. I don't know how many folks were at AI UK, but when Professor Dame Angela McLean, Chief Scientific Advisor, was asked like how important is the environmental impact of AI, she brushed off the question quite. She was very dismissive of it, and she said until it's a problem on the scale of heating people's houses, and basically it's like it's not a problem until it's a really big problem. And that being said, at the top levels is going to mean that this is never going to go up the agenda to the places that we'd like it to. And it's great that we've got folks like Wellcome, and it's the funders really that need to put the pressure, but some funders ultimately are, very tied into government positions. So I think we need to be influencing at the high levels as well. And we need to be aware that we can't wait until it's a massive problem. This is something that we can work to address now. And wouldn't it be nice if we addressed a problem early rather than wait until it was very urgent?
Thank you. Yeah, that relates to one of the questions as well, that you might want to answer as well, is how does the carbon footprint of computationally intensive software compare to the carbon footprint of other things, such as plane travel, meat eating, etc.? It might be early stages, but I think it's interesting to talk about it now and how that growth or how that increase as well will be.
I think that's one for Loïc.
Yeah.
No.
Okay. It's hard to quantify. I'll just throw a few numbers. There was a study looking at large language models, and they looked at GPT-3, so one of the ancestors of ChatGPT, because obviously, again, no data on ChatGPT because we wouldn't want people to look at it. And GPT-3, they estimate to train it was around 550 tons of CO2 equivalent. For context, the IPCC target is 2 tons per person and per year. Planetary boundary is just under 1 ton per person and per year if we want to keep Earth habitable. So that's a lot of people for a year to train the model once. And that was GPT-3. Then we had 3.1 or 2 or 3 and then 4. And that's not to say it's not great to have innovation like that, but it is very significant. We could put it in context of planes, and it's like thousands of flights around the world all the time. Individual analysis. Basically, we're very much in a world where individual research projects or individual analysis can get into tons of CO2. That's very much where we are. In bioinformatics, we did a study. We found that a genomic analysis could be 17 tons in some cases. Someone asked about planes. That's basically flying from London to Paris for breakfast every morning for 6 months and then back to the office, which is not great. I mean, nice, but not great for the environment. So it's hard to have an overview of the field just because we don't have data. It's mad that we don't know the entire electricity usage and therefore environmental impacts of data center providers in the UK because there aren't that many. So we need more data on that to understand it. But we're very much in a world where analysis can be more than travel. And for scientists, if you do HPC, that's probably the biggest contributor to your carbon footprint more than anything else you're doing. So hopefully that's a good enough reason to think about it.
Can I just, as a follow-up on that, there's a question, maybe the overall picture is still a lot of work to do, but is there an idea of existing understanding of which processes in research computing are the most or least impactful? Is it HPC, cloud, data storage, CI, hosting, local development, etc.? And where should we prioritize our optimization efforts?
Yeah, probably for me. It's a good question. I would say it's most likely compute for most people, or storage. So, storage, there are lots of numbers. If you want an order of magnitude, around 10 kilograms of CO2 equivalent to store 1 terabyte of data for a year. That's roughly what it takes. It depends on a lot of other factors. So it all depends. If you're doing astrophysics and you're responsible for generating the data, then most of your impact is probably data storage. If you're using publicly available data that a lot of people are using, then it will mostly be compute. Data transfers, I'm kind of tempted to ignore it. It's just because the electricity it gets a bit nerdy, but the electricity consumption of networks doesn't depend on how much data goes through the network, because basically the electricity consumption depends on how big the pipe is, and that is just calibrated for Saturday evening Netflix peak viewing, or the World Cup final. And so if you're not at peak capacity, then it doesn't really matter if you're transferring data or not. The electricity consumption is going to be the same. Obviously, the more data we demand, the bigger the pipe we have to build, and it's kind of a long-term problem. But in the short term, it doesn't matter so much. So it's very much compute, storage, and behind all that, it's a balance between electricity usage and also manufacturing hardware. And we talked about the life cycle cost. I mean, in your smartphone, 98% of the environmental impact of your smartphone is only manufacturing. So it doesn't matter how much you use it. What matters is keeping the iPhone a little bit longer. Servers, it's a bit lower, but it's still 40 to 50%. So yeah, it's very much multifaceted, but that's why it's important for RSCs and experts in the field to go on and say, okay, well, that's the analysis we do. Let's use online tools or whatever to have an understanding of our carbon footprint, because it's really hard as an outsider to tell people what to do. So that's why we're trying to get everyone involved here.
Yeah, and I think in relation to that, there's a question about change often involves lobbying. Who needs to be lobbied, and who is going to do that lobbying? I don't know if that's a question either Cass or Kirsty would like to answer.
I mean, I totally agree. It's not something I have a huge amount of experience with. I think at the grassroots level, we can do a huge amount, and that's brilliant. But unless there's changes at the top, at the senior levels, it's not going to feed through. I think we can be in a position we can make sure that we're in a really good position to act when changes at higher level are implemented. But in order to get those higher level changes, there does need to be lobbying, and it needs to be, I think, systematic in terms of kind of there's a bit of a strategy and a bit of a target around it. But I worked in climate for a really long time, and when I first joined, I kind of was of the kind of naive impression is we just need more data. If we get better climate models, we can really understand the climate, and then change will happen. And I'm so disappointed that just hasn't happened. We've known, as Michael said, we've known about this problem for such a long time. It's not new. And the climate models actually going back to the 20, 30 years ago, pretty accurate. This isn't a surprise. None of this is a surprise. Change should have happened a long time ago. So really now we're catching up. So how you go from that situation where the science has been there for a really long time, the knowledge has been there for a really long time, a lot of the motivation at the grassroots level has been there for a really long time, and change has not happened. I don't know how to suddenly break this. I'm hoping the urgency of it will suddenly, hopefully, have some effect at the senior level, but I'm not completely optimistic. But I also think it's so important and we need to try.
Thank you. Cass, would you like to respond? Or
I mean, it's depressing, isn't it? In comparison with like the climate science stuff, and the suggestion is that there are people who are stopping the change from happening. There are people making vast amounts of money from oil and carbon that are keeping those products. And I don't know what the equivalent is here, right? Obviously, there are big companies making lots of money from us using and buying their AI products, and we're increasingly encouraged to use them. So, I think about the power and the money, and it's follow the money. And I think also that I have to believe that it is possible. I have to believe that it is possible that we can affect some change, and we just have to keep pushing. And when we get the right people interested in this, then change will happen. I think it's often useful to position it to folks as a how does it fix a problem they have. So we talked yesterday in the speed block thing about folks at data centers are very aware of their energy use because they have to think about cooling and things like this. So as soon as we can make doing this thing of being aware of your carbon have an operational benefit, then that's when we can expect a shift. I think, you know, when there's things like taxes and penalties and penalizing big players for their contribution to this climate mess that we're in. And I think until we see those penalties, then it might be difficult to see much of a shift. But then we know penalties are just, or fines are just people who can afford to pay them. It's not a problem. You know, this isn't just a local issue. This is a global issue, and the disparities of how much people in different places are affected are massive. So, you know, the impact of running a model in Spain is different to running it in Switzerland, for example, and then again in different places. So a kind of coordinated effect is going to be necessary. But, you know, I'm generally, I don't like the sort of climate doom thing, but I am scared. And, you know, that's what keeps me motivated to do the work, really, because, you know, like Michael, I've got my children, and I think we have to keep pushing, even if we're not convinced that what we're doing is working.
No, I mean, that's really interesting on who to push on. And I think one of the big changes that has happened is like environmental impact, energy efficiency used to be a topic for data center people and HPC teams, and maybe RIC to an extent, but mostly people building hardwares and building data centers. And for a weird reason, for years, it didn't really transfer. I mean, they've been doing it for decades, and it never really reached end users. So like scientists or people using the HPC on the ground. And that's partly why there was no cultural change, because, you know, they were like, sure, they will make everything more efficient, but we don't really have to think about how we use it. And that has started to change over the past 4 or 5 years, partly because the boundary between HPC people and users with AI kind of started to change. And now we see more and more initiative, which is good to see. UKI taking up the issue, Wellcome taking up so the big funders, the French government. So these big players saying, well, actually, wait, you are the end user, you are the one applying for funding, but you do have to think about your environmental impact. And that's something wet lab research have been doing for years. For some reason, computing has been lagging behind massively because we don't see the plastic being used. We don't see the carbon footprint. It's all very remote. And so I think I'm kind of hopeful that we're moving in the right directions. For that at least. And in terms of lobbying, well, there are like convincing scientists on the ground and institutions, and that's something everyone can do, you know, convincing your head of the lab that, yeah, we should maybe think about that, or your local, you know, research institute. And I think working with funders, a lot of people have done great work, and there are more and more like convening initiatives now, so that's really good. In terms of lobbying big companies, and the topic came up, that's hard. I mean, we had such an enormous pushback when we started working on this green algorithm project. And it is quite special as a PhD student to be attacked by like massive AI leaders that I will maybe not name, but if you find my slides, you'll find them. And you know, just saying there is no carbon footprint, and it's people like being massive actors in the field, and they just say, stop working on that, these people are lunatics. So I'm not overly convinced that we will convince these big cloud providers very easily. And I don't really try to convince them. I think the pressure will come from customers and say, well, fine, you know, you don't have to be convinced of it, but if you want our money because we have this big grant and we need to set up this big cloud, we will only do it if we can be completely transparent on environmental impact. And if you can't be, fine, we'll find another cloud provider to do it. And I think if we can be a lot more strict on that, and a lot of large actors have I mean, in the UK, you know, things like a large cohort or large trusted research environments where basically it's a big contract with a cloud provider for many years, we can have a lot of leverage on that. And I think that's probably the way to lobby. But I mean, it's not to say that there aren't people very concerned about that in big companies. I'm not saying that at all, but the fact that there are these like key players fighting back quite hard makes it difficult.
Yeah.
I think to make that easier, I totally agree, but to make that easier is if in the way that academics are kind of graded and assessed and stuff, if it's recognized that if I choose to run my experiment somewhere that does give me an environmental impact, even though it takes slightly longer or whatever, at the moment that's not recognized. I don't get a better ref score or anything like that because of that. It would be really nice if academics, if the funders and the kind of the wider research environment recognize the fact that, and then that empowers us to have that voice. I think that would be really useful.
Sorry, No, but just a really cool case that came out of the French implementing it is exactly to respond to that. Some people who were applying for this AI funding call said, oh, wait, instead of buying new GPUs, we're going to reuse GPUs we have before, which normally wouldn't be put in a grant because there's no added value. Like the funder doesn't really care because it's not a big difference in money. It was massive funding call. But this way they could put it in this environmental impact statement. They could really put it forward and say, look, we're actively doing that. It makes sense financially, but also it makes sense for environment, and it would increase their chance. So it was a nice case of actually giving a reason for people to be more sustainable in a way that increases their chance of getting grants and increases recognition. So I'm hopeful that this mechanism already happened a little bit and there's more possibility for it.
Yeah, no, I definitely want to end on a positive note as well. So before I will ask some speakers to talk a little bit about the concrete initiatives that people can get involved with. I just wanted to make sort of a larger point, and that brings us back to the start of the panel where we talked about the urgency of this. And we talked a lot about sort of the environment and things like that, but there's also one question here that I think is important to sort of quickly address. And that's many poor carbon related choices of people in power in this room won't affect them yet, but may affect people in other parts of the world, for example, close to the equator or where flooding becomes an issue. How often are the people affected in this conversation, and if it's bad, and can we improve it? Is that for Cass?
Yeah,
Your wing looks at Cass. Would
Can't
you like
see
to
your
comment?
eyes from here. I couldn't take that subtle signal. So to rephrase, to just to say the question again, it's about the fact that the choices of the people in the room affect people who are not in the room, right? It's like the recognizing that this is a global issue and we have power. And yeah, I think it's kind of like the wet lab example that Loïc said. And when you can see the impact, then you're like, oh my gosh, this is actually happening. And I think we are seeing that more in our room, as in like in the UK or in the West. And as troubling as that is to see it, I actually think it's like, okay, now you see, like, and now have you seen how wet and warm this winter's been? And are you ready for how dry this summer's going to be? And yeah, I don't know. Obviously, we keep erasing the agenda. We keep making people aware of it. We keep elevating voices that aren't represented, and we keep bringing them into the room, and we keep talking about it. But it's also, I think, sadly, it's going to be a case of people will need to see it with their own eyes, and they need to see it affecting their house before they will really take it seriously. And I would desperately love for that to not be the case, but I really do think that is the case. And we keep, but it's just people are selfish. People only care about what's relevant to them unless they're made explicitly aware of the impact on other people. I sound really miserable about these things, but
No.
I've been scared for a long while.
Yeah. So maybe end on positive. How can people in this room today? What initiatives can they do? What can they join? Groups, study groups.
I mean, the good thing is there's loads of stuff available. There's lots of communities starting out. If you're a research software engineer or interested in research software engineering in this space, then we've got the Green RSE Special Interest Group. I think it's also just about talking about it. It feels slightly awkward, also like socially, when you're the person that raises this at, a dinner party or whatever, and, it doesn't make you popular. But I do think that the more that we can kind of normalize discussion about this and engagement around this, the easier it is. Reach out to your institutions, see if there's lots of institutions are increasingly doing environmental teaching as part of their onboarding process, or there's a carbon literacy training that you can do at many universities. So really gain a little bit of knowledge. It doesn't have to be a lot, but there's loads of resources out there. And start just having that conversation, talking to your peers, talking to your colleagues, talking to people that are head of departments, as well as talking to the communities that are being set up. I think the more that we can talk about it and keep it in the agenda, the more likely it is that these changes will happen.
Thanks. Yeah, no, I mean, the bit about it being a bit awkward is totally true. I mean, I'm data scientist by training. I would love to do like radiogenomics all day and cardiovascular research, and not be the like person saying, maybe we shouldn't do all that because it's a bit depressing. I mean, I completely agree. I think I'm just going to like kind of preach for the two things I push forward, because I think that's if you want to do something, this community of practice, I think, is a good place to have exactly this place where people can ask questions. And it doesn't need to be a place where everyone needs to be engaged 100% all the time, because that's especially a place for people whose focus is not environmental sustainability, but just have a place to engage with that as a side aspect, because it's just an essential part of research. So if you want to help with that, a very easy thing is, I put the link on the Slack, is to, even if you want to leave it later, just help it getting momentum at the start would be really useful. So go on there, as I put on the Slack, if you just put one post somewhere, so we get like kind of a moving start, a running start when we launch it next week. That would be a very good thing. And the certification is also an easy thing, because the first bronze level will be very straightforward. It will be more like doing an audit of what's going on in the lab, including it in training and stuff like that. So that might be an easy place to start. So yeah, we'll just push for that for now.
Perfect. Cass, would you like to add to anything?
Yeah, I consider myself to be a climate aware person, but I really didn't understand this issue until I started to hear people that I respected talking about it, invited to a thing, and it's talking about it, it's so easy. There's so much awareness around, what we eat and don't fly. And I imagine most people in this room take some steps to minimize their carbon impact and the damage they're doing to the planet. But why don't we know about this? Why aren't many of us aware of this as a problem? So absolutely, keep talking about it, keep asking questions, tell everyone, and it will trickle up into the right places. Even if you want to, I worked with someone in neurosciences who has been talking about this for a long time in neuroimaging. And when she started talking about this 5, 6, 7 years ago, she was the weird person. And then we encouraged her to set up a special interest group in the brain mapping community. And then that collected people. And she used to think, well, I'm just a brain imager. What am I going to do about the impact of my work? But now she's a PI, and she started a whole program of work about minimizing the intensity of carbon usage in brain imaging and things. So even if you think what you're doing isn't now going to directly, you can't be part of the change, you can by just talking about it, and who knows where things can take you. And even if you're not going to be leading the change, you never know if the next person that you speak to might be someone who does want to take that challenge forward, and then you get a PhD student who can run with the project. So yeah, don't be afraid to not know enough about it, but do keep talking about it.
Thank you. Yeah, so that's the title of our panel, was the digital footprint revolution, a call to action. So I think we encourage everyone to be part of that acting. But we are through the time, and I would really like to thank the speakers, thank the audience for the questions. We really enjoyed it, and hopefully this will be the start of something. So thank you very much. Thanks for everyone.